A determinant of a 2 by 2 matrix, A, and they give you A, B, C, D just as the matrix. First of all, pay attention to the notation. This means matrix when it looks like absolute value of that capital letter. They're talking about the determinant. It can also be noted like this, abbreviated determinant with an A. In fact, when you use your calculator, which we'll do later on, that's what it looks like in your calculator. This is the determinant. You multiply your diagonals and subtract. Always subtract. So you multiply A and D first and subtract the product of C, B. So you're just multiplying your diagonals and subtracting for a 2 by 2. All right? So very, very simple. Multiply 6 and 8. And subtract 5 times negative 2. Pay attention to your positives and negatives. It is always subtraction between them. However, if you're subtracting a negative, right, it's going to add. So in this case, you end up with 48 plus 10. Your determinant here is 58. We will use determinants for inverses and such. All right, that is your determinant. All right, 3 by 3. There's actually 2 ways to do a 3 by 3. Whichever method is okay. It doesn't really matter to me. I actually prefer the other method, but this is the first method they show. You can take a 3 by 3 and you can basically shift these 2 rows and copy them over here. Instead of having one diagonal from left to right and one diagonal from right to left, you have multiple, right? You have 3. And so you can just rewrite it, add your first 2 columns here, and then you do a product plus a product plus a product minus product, product, product. I will say, pay attention to this right here and the fact that they group it. It is imperative that you group it because order of operations will mess you up if you don't group these additions, okay? And so you can multiply your diagonals minus the product of your other diagonals, the sum of your products there. So this is one method. 3 diagonals minus 3 diagonals. That's a 3 by 3. And so we're going to do one that way, just so you can see it. So if I were doing this, I would copy these first 2 rows and I would slide them over here to create something like that, right? And then I would do product of the first set of diagonals. So I would say 2 times 5 times 1 plus negative 3 times negative 1 times 4 plus 4 times 0 times 6. All right, and that is one group, right? You have to group them. And then you're going to always subtract here. And then you're going to do bottom left to top right. So we're going to say 4, 5, and 4. Plus 6, negative 1, and 2. Plus 1, 0, negative 3. Right, and then you just do your operations there, right? So 2, 5, and 1. 3 and 4, that ends up being positive because of those 2 negatives. And then, of course, we have a 0. And then we have 4, 5, and 4. 6, negative 1, and 2. And then another 0. Right? So this is just basic. At this point, you're just doing order of operations, right? So we have 22 minus 68 equals negative 46. That would be our determinant using diagonals. Okay? Questions on that method? The minor of an entry. Remember, the entry is the element, and then they tell you where it's located with those little 2 numbers beside it. In a square matrix, is notated with a capital letter, M for minor, with the same row and column setting. And it's the determinant of the matrix formed by removing the row and column that that particular element is in. The cofactor of the entry is when you negate it. So first of all, let's talk about the matrix itself and what all of that is saying. So if I wanted to do the minor of, let's say, this 2, okay? The minor of the 2 is going to be the 2 by 2 determinant of what's left over if I were to take out the row and column that that guy's in. So if I were to take out this row and this column, that's where my 2 is, right? Then I would find the determinant of this 2 by 2 right here. That's the minor, okay? Cofactor is when you multiply by really what's in that 2. So if I'm going to take that 2 by 2, then I multiply it by that 2. They give us some examples here. They said, let's find the cofactor of C11. All right. You'll notice that we have this positive 1, this negative 1, and this positive 1. Well, where are they getting those? They're getting it from this pattern right here. Okay, this pattern right here. They call them even and odd positions. You start in the top left corner, and really it's goes alternating. So you see it's positive, negative, positive, negative. It would keep going. I mean, however big your matrix is, that would keep going. And then you'll see it goes positive, negative down as well. So your top left corner is always positive. It creates a diagonal of positives, and it keeps going like this, positive and negative diagonals, right? And so, for example, when they did this one, to get this minor here, they did the 2 by 2 matrix, so the same one that I was talking about up here, this 2. They said they wanted the minor of the 1, 1 position. So I go to row 1, column 1 position, that's that 2. And they want the minor. Well, the minor is the 2 by 2 that's left over, okay? So here's the position. Right here, they tell me the position, 1, 1. I find that position, that's right there. And I really ignore the row and the column of that position. And I take this 2 by 2 that's left over and do that determinant. 5 times 1 minus 6 times negative 1. The minor of the position 1, 1 is 11. All right? If I look here, the minor of the position 1, 2. Row 1, column 2, that's that negative 3. You'll see they just ignored the row and the column that that negative 3 is located in. And then they took the 2 by 2 determinants. 0 times 1 minus 4 times negative 1. There we go. The minor of that guy is 4. All right. 1, 3 over here. Same thing. They did the minor. Okay. Then they determined if it was positive or negative. That's what that cofactor means. Now determine what position that guy was in. Was he in a positive or an even, or was he in a negative position, odd? Okay? And so for this guy right here that lines up with this is a positive position. This would be positive, 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 negative, negative, positive, right? And so it just creates these diagonals of positives, negatives. So when they did the cofactor here, they just multiplied by positive 1. It didn't change. But this right here is in a negative position. So they multiplied this one by negative. This one is in a positive position, so they didn't change that one, okay? And so that's going to help us do determinants of 3 by 3s a secondary way, using your cofactors, okay? So let's look at using your cofactor to do a determinant. They have all these words. Determinant of an n by n matrix is the sum of the product of the entries in any row or column and their respective cofactors. For example, expanding the ith row, and they give this to you. What does all that mean? Well, you choose a row or a column. It doesn't matter which one. I always choose the easiest. If there's a 0 in the column, I'm probably going to choose that guy, right? Because he's going to 0 out. And you use that column and every single number in the column to multiply that by its cofactor, and then add those up. That's what we're doing, okay? So like if I were doing this, my personal preference here would be this one right here, column 1. Why? Well, because one of my guys is going to 0 out. Okay? They want us to do it two ways. So we're going to do it two ways so you can see both ways that we do it. The first way they want us to do is using row 1. That's this guy right here. All right, so row 1, we're going to use that to find our determinant. And so I'm going to choose the 2 first. So I'm going to start with a 2. So I'm going to say 2. It's in a positive position, so this isn't going to change. It's going to be a 2. And I will multiply it by the 2 by 2 determinants that is left when I ignore the row and the column that 2 is in. The 2 by 2 that's left is 5, -1, 6, 1. So I have 5, -1, 6, 1. That's my first one. All right? I'm going to add to it the 3 position. That 3 position is in an odd position, right? So I'm going to change that sign. It's going to be a -3 times a -1 before I do that determinant. I have to change the sign. And then I'm going to do the determinant of whatever's left when I ignore this row and this column. All right, that's 0, -1, 4, 1. Right? And then I'm going to do the last one, which is the 4. It's in an even position, so it's positive. I'll leave that guy alone. And I'm going to do the 2 by 2 that's left here, which is the 0, 5, 4, 6. All right, that's the other method, right? So it's not hard. We're just going to say, well, this is going to give me a 2 times the 5 minus a -6, right? This is going to give me a 3 times the 0 minus a -4. This is going to give me a 4 times the 0 minus 20, the 2 by 2. And so then I'm just going to add it up. So I have 22 plus 12 minus 80 equals -46. That's that guy. So why would I have chosen the first column, B, here? Well, because I have one less guy to do, right? When your outside guy is a 0, 1, you don't have to worry about its positive or negative. 2, you don't have to worry about what the determinant is. It's going to be times 0, right? And so if I were to do this column instead of the first row, I would only have to do it twice. So this first one's going to be exactly the same. It's going to be 2 times that 5, -1, 6, 1. The second one's going to be 0 times something. I don't even write it out. I don't have to worry about it. And the third one is going to be 4, but it's times a different determinant. It's times this guy right here. So -3, 4, 5, -1. And so then I'm going to do exactly the same thing. This is going to be the 2 times the 11. This is going to be 0, right? And then this guy is going to be 4 times the 3 minus the 20, right? Which should also give me 46. All right, questions on doing it that way? All right, try one. So there will be times when I give you 2 by 2s and 3 by 3s that I say, use this method or this method to solve. And so I must see that you've used either the diagonal method or the cofactor method, right? I must see that work. But you're welcome to check it. It's a nice check mechanism. If I ever give you one larger like this, I'm not going to require you to show me a method because it's going to take you all day to do that, right? So on your calculator, you have this matrix button. You have to get to it by using this second and matrix. When you do that, you actually pull up a screen that'll have A, B, C, D, E all the way down, right? And so if you go into it, you will see that you have 1 with an A, 2 with a B. If you have a TI, you should see that concept, right? And so if you are on it, you can go over to the edit. So you can go all the way over to edit, hit enter, and then it gives you the option to tell the dimensions of that matrix. So by the way, if you have other matrices loaded, you have to, on the edit screen, go down to a new one that is blank, okay? And you'll see the dimensions. It defaults at 1 by 1. You can put in 4 by 4. And it'll create this 4 by 4 matrix, right? And then you go through and you add all of your elements to your matrix, right? It goes across. So it goes by rows. So as you enter this, you can hit 1, enter, 2, enter, 0, enter, -1, enter, and it drops you into the next row, okay? So it'll let you enter all the way across until you have filled in the matrix all the way across, right? And then you'll notice that if you go back to your matrix screen, you have a 4 by 4 matrix in that position that you just loaded, okay? And so that's how you load the matrix. That's how you load it. And then on your matrix screen, once you've loaded it, you can go to math and you can do the functions. So once you've loaded your matrix, you should be on your home screen here. So now you're going to go into your matrix menu. So second, usually X to the -1 on most TIs. Go over to math in that menu and then choose option 1, determinant. And on your main screen, you should see the notation for determinant that looks like this. It should have opened a parentheses. All right. Now you're going to go into your matrix menu again, second matrix, and you're going to choose the matrix you just loaded. Whatever matrix. If it was A, go down to A and hit enter. It will have thrown it into brackets like this, right? Close your parentheses and hit enter. So this equals 6.